Today we will discuss about how the energy bands they are formed. Now let's consider an isolated silicon atom. This is a silicon atom of atomic number 14. That means there are protons inside the nucleus. Inside the nucleus, protons are equals to 14. And electrons are like that. 2 electrons in the first shell, 8 electrons in the next shell, and in the valence shell there are 4 electrons. Okay. This is silicon atom, atomic number 14, and atomic mass, this one. You know, energy levels of silicon atom, they are quantized. Quantized means the valence electron. There are 4 valence electrons. They are having, you know, in the levels of fixed energy, right? Actually, you can study the Bohr model for hydrogen atom. Hydrogen atom is the simplest atom having only 1 electron. But you know, the Bohr study tells us about what are the different energies associated with the different energy levels in case of the hydrogen atom. When, like, this is 1 atom, and this is a this is a second atom. Okay, when they are far apart, there is no problem. Their energies and electron energies are fixed. But when they are brought close together, what happens? Then quantized energy levels, hybridize. Hybridize means it comes a change in the energy level of the valence electron. Okay. And split into the 2 different levels. You know how? Like, this is 1 atom. Let's take an example. There's a valence shell. Okay, this is a second atom, the same one, and having again it also having the valence shell. Let the energy of this valence shell is 2 unit. Energy of this valence level is 2 unit. It's okay when they are far apart. Close, when they come close, what happens? The energy which is 2 unit, there may come a change, and it may become 1.9. So it is also, you know, close to this one. Very close to this one. So energy of this level will change from 2 to 2.1. So instead of having now 1 energy which is 2 unit, now we are having the 2 different energies, 1.9 and 2.1. How? When it happens? When atoms are brought closer, their energy of the valence shell changes because of the mutual interaction. interaction of the electrons of this atom, interaction of the electron of this atom. So electromagnetic interactions takes place. So it happens a change in the energy level. So we say splitting into the two different energy levels, okay, like 1.9 and 2.1. So energy level splits. If the n atoms, we are having the n atoms. If two atoms, two different energy levels formed. If n atoms and moved closer, what happened? Interatomic distance, they are closed such that the distance is now interatomic distance. So energy levels split into there are n different levels. Now these n levels, they are very close to each other. And if n is very large, so instead of like that, we are having splitting like this. Okay, we are having like 1.7, 1.8, 1.9, 2, 2.1, 2.2. I'm just taking the example. Actually, there is not much change in energy. The energy difference is too small. And if from here to here, there are a very large number of continuous levels, very large. Instead of looking at discrete, so this area becomes continuous when n is large. So it is a continuous, area. So thus splitting up new levels, and new levels, they are continuous in some area. That is called a energy band. The important facts. If the atom is isolated, then having definite and discrete amount of energy, there is no splitting. Okay. And the unit of energy, shells and subshells. The unit of energy is electron volt. Electron volt, like this, not with like this. So this is the case of the isolated atom. There are three shells, D1, D2, and D3, and every shell having a fixed energy, like this one, this one, this one. There's no splitting, no broadening. Now, in a solid, if you take a volume 1 cc 1 centimeter cube, then they are roughly 10 raised to power 23 atoms, roughly. Okay, so just imagine how the atoms, they are close enough. In 1 cc contains 10 raised to power 23 atoms. So they definitely influence on one another. One atom influences to second, second influences to third, and so on. So each atom is surrounded by electrostatic fields of the neighboring atom, and then interactions takes place between the electrostatic fields. So atom begins to influence each other due to interatomic interactions. So modification of the energy levels happens. So looking here, when atoms they are brought close together, then this D1, it is broader. There is a broadening from here to here. I mean, this atom may have D1 energy, any energy from this, this shaded levels. D1, maybe D1, this one, maybe D1 energy having this value, maybe D1 energy of this value. So D1 may be anywhere, any value between this portion, between this shaded region. Similarly, D2, there is a broadening of D2, and atom may have any energy between this region. Likewise, D3 D3 may have any energy between this region. So this broadening of D1, D2, D3. Why it happens? When you brought the atoms close together and interactions takes place. So that's why. So with the result of interatomic interactions, small change comes in the energy of the remember one thing again, there are inner shells and the outer shell. The much change, there will be large change or more change will be in the outer shell, and small change will be in the inner, because inner shells are shielded by the outer ones. So inner one are not much affected. Outer one is more affected. So energy of the outer shell is more affected due to the interactions as compared to the inner shells. And this broadening is called, broadening of the energy level is called energy band. So silicon atom made up of N atoms, and electronic configuration of silicon is 1s2, 2s2, 2p6, 3s2, 3p2. So outer shell having 4 electron, 3s2, 3p2. The capacity of 3p levels, it is 6 actually. 6 electron can accommodate. Okay, and 3s is okay, having capacity of 2. So total level are 6 here and 2 here. Yes. Okay. So total levels are like that. 2s, 3s having, how many levels? Like 2 levels. 3p having 6 levels. So total 8 levels with the one atom. Okay, and if there are n atoms, then how many levels? 8n levels. 8n levels total. Right? So 3p levels is 6n because there are n atoms. And 2n levels for 3s. And there are total 6n and 2n, 8n. Out of the 8n, 4n are filled and 4n are empty. So this is the graph between the energy and interatomic spacing R. What is the point here? We are having the 2 atoms, one at here and one at here. And what we do? We will bring this atom closer, closer and more closer. Like that. When we reach at here, what about the energy between the levels? When we reach here, what happened to energy? When we reach here, what happened to energy? When we reach here, what happened to the energy? Okay. So when one atom is here, one atom is here, and then the distance is too much, and there will not any change in the energy levels. Right? There will be no change in the energy levels. And 3s level and 3p level. This is 3p. This is 3s. When one atom is here, second one is here, that means R is greater than E, then levels are having fixed energy. Closer, and you reach at here. When one atom is here, one is here, silicon case, even then the energy is fixed. Now when we are coming more closer between A to B, what happened? Splitting starts. Splitting starts. This energy level is splitted up. This one is also splitted up. And reaching it here, there is a splitting of 3p from here to here and 3s from here to here. So when you are at P, 3p are splitted up from this level to this level. 3s splitted up from this to this level. When you still more closer, like that at here, what happened? Now splitting, there is more broadening of 3p and 3s. There are more broadening of 3s and 3p. Okay, when you reach it here, before C, before this point, there is a distinction between 3s and 3p. 2 levels are filled of 3p and 2 levels are filled of 3s. But reaching it here, there is no distinction which are 3s level and which are 3p level. The level becomes continuous. Now still coming closer, when you reach it here, again some levels are here some levels are here. These are the levels now which are filled. How many filled? If there are n atoms, 4 n levels they are filled. Okay. And 4 n levels they are empty. Occupied levels and empty levels, they are now being separated from each other by some energy gap. Okay. So this is called the filled, filled levels, continuous level, they are called valence band, and empty levels called the conduction band, and there is an energy gap between the two. This is how it happens. So again I just review it. One atom is here, one atom is here. Far distance, there is no change in 3s and 3p. Coming closer at here, splitting starts, broadening starts. The broadening is continue. And reaching at here, the broadening is too much and distinction disappear between 3s and 3p. So coming more closer, so something different happens. The filled energy levels, they are separated from the empty ones, and there comes a gap between the two, that is called the energy gap. Okay. Now if we consider an example of semiconductor, at 0 Kelvin, conduction band is totally empty. So that means no electron in the conduction band. That means semiconductor is a perfect insulator at 0 Kelvin. You know what is 0 Kelvin? You go, the ice, water freeze at 0 degrees Celsius. So you go down minus 273 degrees Celsius. That temperature is called 0 Kelvin. Okay. Now what happens? There is a valence band and there is a conduction band. And electrons may jump from valence to conduction. When electron jumps from valence to conduction, the electron will come here and it left an empty space here. So this electron will be free to move in the conduction band and hole will be free to move in the valence band, and then they constitute the current. Now how it happens? At the room temperature, because at room temperature some energy is available to the electron to jump from valence to conduction. So when the electrons are available in the conduction band, then apply the potential difference, mean voltage. Then that voltage will force the electrons to move in a preferred direction, and then they constitute the current. Now what are the good conductors? Good conductors are those having very large number of electrons in the conduction band. So when the electrons comes in the conduction band, they are having greater mobility and are responsible for the conducting the current. for electrical conductivity. Now, what is the forbidden band? Forbidden band is the energy gap, the space between the valence band and conduction band. This space is called forbidden band. Forbidden means no electron can exist in this space. Okay, the electron can have the space in the valence or in the conduction, but not allowed to have in this space. So that's why it is called, this is called the forbidden band. So this is valence band, this one is the conduction band. So this is the energy gap between the two. So this is energy level of top of the valence band. This is energy level of bottom of the conduction band. So at 0 Kelvin, this is totally empty. Okay, this is totally filled. Semiconductor case at 0 Kelvin. So this is the case when atom is isolated. There is no broadening. This is the case when the atoms, they are close together, close enough, like in a crystal. So there is a valence band, there is a conduction band, there is an energy gap. So this exercise for you, if the energy gap is 6 electron volt between valence and conduction, what is that element? And of course, a hint is 6 electron is too much energy gap and cannot overcome by electron from valence, cannot overcome by the valence electron. So it is very difficult to have the conduction with such type of element. But if the energy gap is 1 electron volt, it is easy for the electron to jump from valence to conduction by absorbing the energy available at the room temperature. So valence band, where the electrons are tightly bound with the nucleus and electron cannot conduct the charge. So no current if the electron are in the valence band. They can move to conduction band by absorbing the energy. So concept of energy band is important for classifying conductors, semiconductor and insulators. The width of the forbidden band between conduction and valence. It decides whether a substance is insulator, semiconductor or conductor. So in case of metal, conduction band and valence band, they are overlapping. So there is no problem for the electron to have a space in the conduction, because a part of some electrons, they are in a conduction band already. They are already in the conduction band. Okay, so a very little energy is required for the electron to conduct in case of metal. In case of insulator, this energy gap is too much, and electron cannot overcome by absorbing the energy even. Okay, so it is impossible for insulator to conduct. But semiconductor, the energy gap is in between the conductor and insulators. Mean energy gap is small, electron can overcome easily.